It's so cool going to the asteroid belt. It's this ring of broken up debris between Mars and Jupiter. These are among the last unexplored worlds in the inner solar system.
Have you ever wondered what's between Mars and Jupiter? That giant zone is called the asteroid belt. It's crowded with space rocks, but there are no planets there. Unlike the rocky planets near the Sun or the big gas planets farther out, something stopped the planet from forming in this spot. But what's the reason for this? Early in the life of the solar system, dust and rock circling the Sun were pulled together by gravity into planets. But not all of the material created new worlds. A region between Mars and Jupiter became the asteroid belt. It's a torus-shaped region centered around the Sun, containing countless rocky bodies ranging in size from dust particles to dwarf planets. About 60% of the main belt's mass is concentrated in the 4 largest asteroids: Ceres, Vesta, Pallas, and Hygeia. The asteroid belt lies about 140 million miles from the Sun and spans roughly 2.2 to 3.2 astronomical units. Despite popular depictions of densely packed asteroids, the objects within the belt are actually spread out over large distances, making collisions rare and allowing spacecraft to pass through without much risk. Over 200 asteroids are known to be larger than 100 kilometers, and infrared surveys suggest that the asteroid belt contains between 700,000 and 1.7 million asteroids with diameters of 1 kilometer or more. Asteroids in the belt are classified based on their composition into several types. The most common are C-type or carbonaceous asteroids, which are dark and carbon-rich, making up over 75% of known asteroids. They are redder in hue than other asteroids and have a low albedo. S-type or silicaceous asteroids are composed of nickel-iron mixed with silicates. These are brighter and constitute about 17% of the belt. Lastly, M-type or metallic asteroids are composed mainly of nickel-iron. These are relatively rare and are mostly found in the middle region of the belt. Our solar system isn't the only one with an asteroid belt. A cloud of dust around a star known as Zeta Leporis, a relatively young star, approximately the age of our Sun when Earth was forming, also shows signs of a similar structure. The main question is why there is no planet in the asteroid belt. Several factors contribute to this absence. Firstly, Jupiter's significant gravitational influence plays a crucial role. During the early formation of the solar system, the strong gravitational pull from Jupiter disrupted the planet-forming process in the region of the asteroid belt. Its gravity caused the material in this area to experience high-speed collisions that were too energetic for the materials to coalesce into a planet. Instead of forming a planet, the materials remained as smaller individual bodies or were scattered away from the region. The gravitational interactions between Jupiter and the objects in the asteroid belt created orbital resonances. These resonances result in periodic gravitational tugs that increase the eccentricity of the orbits of the objects in the belt. The Kirkwood gaps in the asteroid belt are regions where these resonances with Jupiter's orbit are particularly strong, further disrupting the formation of a planet. Moreover, the total mass of the asteroid belt is insufficient to form a planet. Estimates suggest that the combined mass of all the asteroids in the belt is only about 4% of the Moon's mass, or less than 1,000th of Earth's mass. This mass is not enough to create a planet-sized body. Another contributing factor is the distance of the region from the Sun. The asteroid belt is located at a distance where the solar winds, which push against dust and gas particles to compress them to form a planet, are weaker. Therefore, the material in this region could not come together to form a planet. Despite the lack of full-sized planets, the asteroid belt is home to a dwarf planet. This vast area contains hundreds of thousands of asteroids, with the largest object being the dwarf planet Ceres. which has a diameter of approximately 950 kilometers. The dwarf planet alone makes up about a third of the total mass of the belt. Although Ceres is cold, with daytime temperatures between -136 and -28 Fahrenheit, it's still warmer than Pluto due to its closer proximity to the Sun, about 257 million miles on average. Discovered in 1801 by Giuseppe Piazzi, Ceres is also the only dwarf planet located in the inner solar system. Initially classified as an asteroid, it was reclassified as a dwarf planet in 2006 due to its size and unique characteristics, distinguishing it from its rocky neighbors. Ceres was explored by NASA's Dawn spacecraft, which revealed fascinating features, such as the bright patches in the Ocketer crater, known as Cerealia Facula and Venalia Faculae. These bright areas are primarily composed of sodium carbonate, left behind by briny water that emerged from beneath the surface and then sublimated. This suggests an underground reservoir of salty water, possibly as deep as 60 miles beneath the surface, potentially indicating ongoing cryovolcanic activity. The presence of water and other intriguing geological features have sparked discussions among scientists about the possibility of past or even present microbial life on Ceres. This interest has led to proposals for future missions, including potential sample return missions. Modern observations and missions targeting the asteroid belt have significantly advanced our understanding of this region. One of the most significant missions in this context was NASA's Dawn spacecraft, launched in 2007. Dawn was the first mission to orbit two extraterrestrial bodies in the asteroid belt, Vesta and Ceres. Dawn orbited Vesta from July 2011 to September 2012, mapping its surface, determining its composition, and studying its internal structure. The mission revealed that Vesta has a differentiated structure similar to terrestrial planets, with a core, mantle, and crust. It also discovered a massive crater, Rhea Silvia, which has a central peak twice the height of Mount Everest and numerous chasms, suggesting a violent history. The spacecraft was equipped with a camera, gamma-ray and neutron spectrometer, visible and infrared mapping spectrometer, and a gravity science instrument. Dawn's journey continued to Ceres in March 2015, where it aimed to study the dwarf planet's surface, composition, and potential for water ice. If a planet were to form in the asteroid belt, what do you think it would look like? Share your thoughts in the comments below. Hope you enjoyed this video. Make sure to subscribe for more updates on space exploration and astronomy.